Hello there and welcome to this course on classification analysis with Python. My name is Valentine and I'll be your instructor for this course. This course will follow the following structure. So we'll get started learning about the learning outcomes of the course. So what is it that we expected to have achieved? We'll then later onwards go to the next section, which just involves learning more about what is classification analysis, what are those fundamental concepts that we need to take into account when we are learning classification analysis. We'll also talk about why we learn classification analysis and when exactly we would need to apply classification analysis. Once we have gone through that section, which will give us a macro view of the entire topic, we'll go into a reading and a quiz. This should take us about 15 minutes. So you will get to go through a curated reading that we have prepared that will actually give you an in-depth perspective of those concepts that we will have talked about earlier on. And this is the reading that you see on your screen. It will be just extensive and it will help you generally to be able to grasp those particular concepts in a really in-depth way. So once you go through this, you'll also go through a reading, which will generally be a short assessment that will help you to see whether you'll have actually have gotten an understanding of those basic concepts in relation to classification analysis. So that you'll get to do within the 15 minutes. Then after that, we'll go into a practice session where you will go through some curated reading, some curated content that we have prepared. So this will involve going through a notebook that will contain an example as well as challenges. And the example will cover classification analysis concepts that we will have actually presented earlier onwards at the beginning of the session through the first two sections. That's the reading in the quiz, and then the what, why, and when sections. So generally, the concepts, the theoretical concepts that we're going to be learning in these two particular sections. So during what, why, and when, as well as reading and quiz, we'll put them into practice during this practice session. Once that is done, once we've gone through the practice work, and you have gone through the challenges and verified those challenges through our solution notebook that we will also provide, we will then provide you with a project that you can be able to go through that will give you an opportunity to put into practice those classification analysis skills so that by the end of the entire learning experience, you are in a good position to work on any classification project that comes along your way. So that will be something that we'll provide after the end, and you can use that for your learning journey, or even just when you apply, you can put this project in your portfolio, and hopefully other stakeholders or maybe potential employers can see what you can be able to do from the skills that you have learned in this experience. So for this project, actually, we've also provided a guiding notebook, which is just a document that has already some curated concepts in relation to classification analysis. But at the same time, we've filled in actually areas that do not necessarily require you to apply classification concepts. So for those areas, you could always consider going through other courses that will help you understand how to work with them. But when it comes to classification concepts, which you will come to, you will need to key in now information with regards to classification that will enable you to provide a solution to the project that you will have been given, which will give you. Then you can also, and we'll also provide you with a solution notebook that you can also use to just verify whether you're able to have achieved what you expected in this particular workshop or in this particular course. So generally, that is the structure that we are going to be working towards. I hope that you will get the most out of this workshop and or this course, and you will be able to continue your learning journey of becoming a data analyst or data scientist or even a machine learning engineer. And hopefully you will create the impact that you would want to create in your field or in your career. So let's get started. So by the end of this workshop, we are expected to have achieved these learning outcomes. So we should be able to recall the concept of classification analysis. We should be able to describe the applications of classification analysis. We should also be able to build machine learning models, which in our case, we would term them as classifiers, to make predictions. We should also be able to evaluate the performance of classifiers while making predictions. Be able to describe the limitation of also using different kinds of classification models. The prerequisite for this course is another course called regression analysis with Python. We also have that course in our platform. You could always go through that particular course. We've provided extensive information on introduction to machine learning in that course. However, we'll also try as much as we can to also touch on a bit with regards to some of the basics of machine learning. If you are still, maybe if you're a beginner, like you don't even have some programming knowledge, you could consider first of all just having gone through some Python experience, because what we are going to be using to implement some of the concepts that we'll go through will actually to use the Python programming language. And once you have gone through the basics, so going through the introduction to Python and programming course that you also have, you could also go, once you finish that, you go through data wrangling course, data analysis and data visualization, and also statistical data analysis. You should also be in a good position to undertake this course with ease. However, that doesn't mean you cannot be able to go through this course. We have in this course ensured that we use the least amount of jargon as possible, but we'll try as much as we can to explain some complex concepts that we think would be critical in your learning journey. Hopefully, you'll get the most still out of this this particular course and be able to even just work on maybe some simple problems. So now moving on, what is classification analysis? So this is a type of statistic analysis technique that we use in machine learning as well as in statistics. And generally, it involves creating simple computer programs or complex mathematical functions which would make predictions given some historical data. So and the kind of predictions that we would be making would be ones where we are trying to predict whether a certain variable will have a particular value or not. So assuming, as an example, assuming that we wanted to determine whether tomorrow will rain or not in a certain region, then we can get the historical data of that concerns weather for that region for the past few years, and then create a computer program that we train using that data that is able to learn more about what is likely to happen tomorrow. And in such a situation, the variable of interest, which, when we tend to work with data, we work with variables, and they're usually what are called independent variables and a dependent variable, which is our variable of interest. In data science, data analysis, we call it a target, we call it a label, usually give it different names, or outcomes variable, but for our use case, we can use a target or a label. So our variable of interest, which is just whether tomorrow will rain or not, would be of categorical in nature. It would be yes or no. The values that would go in that variable would be yes or no. Either you can think of just a variable as just a column in a table, and other variables, the same case, columns in a table. So inside the variable of interest, the values that we would expect would be categorical in nature. In relation to another type of analysis, when it comes to machine learning models, when it comes to machine learning, there's what is called regression analysis, which is actually almost what we have described, only that the target variable is usually continuous in nature. It's usually that we are trying to predict a certain value as opposed to a particular category or class. So for classification, we are usually trying to classify the value for a variable that might be of our own interest. So generally, classification analysis just involves categorizing data into what are called predefined classes based on some independent variables, or what we call input features or attributes. So the independent variables in a data set would be now those features or attributes. In a classification analysis situation, we would normally have a data set, again, which has a variable of interest, which is categorical in nature. And other examples would be other examples of variables of interest, maybe in different scenarios, would be whether a customer will likely return to a shop or not, whether they will churn, like, whether they'll leave the service that is being provided or not, whether maybe a student will pass or fail, whether a patient has cancer or not. So the variable of interest is usually categorical in nature. So, and when we're working with data, we have numerical variables as well as just categorical variables that we can work with. So the idea also, when we are creating this computer program, which is our machine learning model, is normally just to give you a good idea of the entire process. Normally, yes, we have a problem. We want to determine whether maybe it's going to rain tomorrow or not, and we have a data set. Now, the data set that we have, we normally split it into different sections. We split it into different parts, maybe two parts or 3 parts, depending on the objective. If we want to work with that data and train a machine learning model and just do that, just training it and then maybe check its performance, we usually split it into 2 parts. But if we also want to tweak it, like to tweak the machine learning model so that it actually makes much more accurate predictions, then we can split it into 3. But when it comes to in most cases, you can split it into 2. So you split the data set, maybe 80% of the data set. If you have 100 records, 80 of the records would be what would make up what is called a trained data set. And that trained data set would comprise of the independent variables or the features and the target variable, which is the variable of interest. So we would use that trained data set, those 80% of the records, to train this computer program, which is a machine learning model, which is just a computer program. We would train this model, and we would we're training it so that it can be able to take, say, for example, new records, new input features, new independent variables, and be able to predict the corresponding dependent variable value for that particular new record. So a good use case, assuming you're working in a bank, you have information about customers who normally come in to your bank, and you want to check on whether those customers will default or not. You can use your historical data of the existing customers. 80% of that data, you split it into a trained data set for training the machine learning model, and then 20% you set it aside for checking the performance of your model. So the idea normally is to ensure that you are able to, you're able to take the independent variables and the dependent variable of the trained data set. You train it with the model, and the model gets to learn more about, okay, for these set of independent variables, this is what happens. So in a case where you want to determine whether a customer maybe will churn or not, then, or even whether the customer will pay a loan or not, then you can use the new customers' independent variables, information that you've collected about those new customers, and you can then try to predict, using that already trained model, the possible new value of the variable of interest, whether that new customer will churn or not. So it helps you to turn around the time it takes in terms of decision making in a really short period of time, in a matter of seconds, and you know exactly whether that customer will churn or not. So I've already talked about different components of classification analysis. I've already talked about input data, which just refers to the independent variables in a data set. Sometimes you can call them features or attributes, and we would normally not really play around. So we would normally engineer those features, independent variables, before training of a model, so as to ensure that the model that we want to train gets the most out of that particular data set. Now, the other bit would be classes and categories. Our variable of interest, that's the other component, normally would have what are called classes or categories. You could have many classes. So in the categorical variable, you could have maybe ones and zeros, A, B, C, D. Like, you maybe have 2 or 3 or 4. Sometimes you could even have hundreds, but it usually depends on whatever use case that you're working with. But in most cases, when we're working with classification analysis problems, you would normally have a categorical variable, which is of your interest. And that categorical variable would have just classes. And when we have 2 classes, let's say yes or no, true or false, in such a situation, the problem, we normally refer to that as a binary classification problem. When it's more than 2 classes that we have in the categorical variable, we normally treat that particular problem as a multi-class classification problem. Training data, I've already talked about the training data. I've already also talked about what a classification model is, which generally would be, you can think of it as just a computer program that you train your data, you use it to train it. You train it with just trained data set, and you can, or training data, and you can be able to use that classification model to make predictions. And classification models or machine learning models in general are normally based off what are called algorithms. So you have what are called, and there are various algorithms. There are logistic regression, there's decision trees, there's random forest, there's support vector machines, which we are going to go through. There's also neural networks. That's also something else for some other workshop in the future that we'll come across. On the other hand, once we have trained our data set, sometimes once we have trained our classification model, sometimes we might want to test that its performance. We want to determine its performance. Is this classification model doing well when it comes to making predictions, or is it not doing what it's supposed to be doing? So generally, we usually use the 20% of data, the testing data or the test data set that we had set aside, not the 80% training data. And then we would, so initially we would, once we have already trained our model, we would take the test data set, then we would split it into the independent variables and the dependent variable. So the dependent variable, those are the values of the 20% values for the test data set that are there. We would put them aside. Then we would take the input features or the independent variables. We take that to the model makes its own predictions, and then we compare the performance. We compare the model's predictions and the original predictions that were there in the data set to see how the model performed. You might realize out of 10 maybe predictions that the model made, it made maybe 1 error. So that means it has a 90% accuracy, or two incorrect predictions, or 3 incorrect predictions. So if it's 3, then the model had a 70% inaccuracy. So generally, that is how you can be able to do that. And there are many different kinds of performance metrics that we can be able to use, and we can represent them mathematically. There's what is called accuracy metric. There is precision. There's recall, F1 score, ROC, AUC, and quite a number of them. We'll get to touch on just a few, but we will leave it up to you for extensive study on those other different types of performance metrics. And lastly, we'll also go through what is called a confusion matrix, which is just a way to visualize the performance of a classification model using what are called true positive, false positives, and false negatives, as well as true negatives. Don't worry so much about what they mean, but we'll also demonstrate that during our practice work. So when it comes to creating a classification model or building what is called a classifier, on the other side, if we're working with regression analysis, which is the opposite of this, we would say we are building a regressor, which is just generally a machine learning model that performs regression tasks. On this other side, it's a machine learning model that performs a classification task. So assuming that this is a process that we are using to work on a project, business understanding, data preparation, then we come into data modeling phase, we would apply classification methods during this particular stage of data modeling, where we split our data set, then we build a classifier, we evaluate the model, and we can even optimize it and then deploy it, or even just present it to various stakeholders. So generally, that is where we can be able to apply or build a classifier, and we'll get to see that. So just a few things to go through. Types of classification. There are different types of classification. So we've already talked about binary classification. This is if you have a categorical variable, which is the variable of interest, which is a label or target, that has only two classes. So you have maybe yes or no, like, you know, maybe this particular customer will churn or not, or you know, this email that is a spam or not, something of that sort. Multi-class classification just involves 3 classes, maybe yes, no, maybe, or yes, maybe, fail, or something like that. Ordinal classification is slightly different. It's only that if when you have the values inside the categorical variable having some sort of order, so you could have maybe unclassified, neutral, and satisfied. Those are the classes inside that categorical variable. Or you could have hot, warm, cold. You know, there's some sort of predefined, there's some sort of natural order in terms of those values, and you'd also want to take into account of that order in your training. So you could use specific algorithms which are much more better for creation of ordinal classification models. So generally, the reason why we would need to learn about binary classification, multi-class, and ordinal classification is actually what I've mentioned, that sometimes actually that each and every types of classification, for each and every types of classification, which are binary, multi-class, and ordinal, there are specific algorithms, that's classification algorithms, that work best for each and every case. So that is something that we'll also get to learn a bit more. These are the different classification algorithms that we will go through. These are the most basic algorithms. We sometimes call them Bayes models. There's logistic regression, naive Bayes, k-nearest neighbor, support vector machine, and decision trees, which we're actually going to go through them right now, step by step, but we won't take much more, we won't go so much into details about them. So something like logistic regression. So just starting off just quickly, logistic regression is an algorithm that we can use to be able to make predictions of a categorical variable that is binary in nature. So if you has 1 or 2 categories, well, 2 categories generally, like yes or no, maybe fail on pass or something of that sort, then logistic regression would really work. How it works, it usually uses what is a logistic function to transform some linear combination of the input variables, which are also called predictors, into some sort of probability score. So the output for each and every prediction using the logistic regression would usually give a value between 0 and 1. So it could be 0.4. If it's 0.4, normally the cutoff point for saying that it could be, if your categorical variable has zeros and ones, values less than 0.5, that's a probability score, would actually be given a 0, and values greater than 0.5 would actually end up getting a 1. So generally, a logistic regression helps you to determine that probability score. So then you can be able to have made some prediction. So when do we use it? If again we have binary, or in some other cases multi-class classification problems, but most cases binary, and also when we also have linear relationships between features or the independent variables and the target variable. So this is something that you can test out using something like a pair plot, which will give you just multiple scatter plots, or you can even check the correlation, the Pearson correlation coefficients for the different variables with now in respect to now the target variable, and ensure that it works. So if that exists within your data set, then this particular logistic regression algorithm is actually a good one to use in that situation. And you can also decide. Then these are steps that you usually take just when you're exploring your data, trying to understand how your data looks like. Also, something else to note is that logistic regression is usually interpretable. So if you do a bit of more digging into this algorithm, you will know that you can use it in many use cases where interpretability is a concern. It's usually about most important. It's not that, yes, you've created a machine learning model based on maybe a certain algorithm, not regression, and you don't really understand how the algorithm makes sense. No, logistic regression is actually explainable. Naive Bayes, we can use this type of algorithm when we especially are working with lots of text data, then and also multi-classification tasks. In most cases, I think because I've used this particular algorithm when it comes to actually text data, a lot of use cases are quite useful. It's quite useful in many of such use cases. It's usually what is called a probabilistic algorithm. So it uses probability concepts, and it calculates the probability of each class that you're looking towards, given the input values, using the Bayes theorem. So there's a whole of maths behind all of this, but the idea is that you get some probability of whether the new set of features will actually end up having one particular class or the other. One of the assumptions, or an important assumption, is that there's always independence between the features, or multicollinearity exists within the input features, which means that there shouldn't be any relationship between your input variables or independent variables. So if there are, you could always drop some of those variables and test which combinations actually work well. So the assumption is that if you're going to use naive Bayes, you need to ensure that the independent variables that you're working with do not have any sort of correlation amongst them. They don't have any relationship. And you can again check this with pair plot or heat map with regards in combination with the correlation values to check on that. This type of algorithm, it's quite fast. It works well for text and categorical data. And it's suitable, again, as mentioned, binary and classification tasks. And it's also useful when you have a data set that has quite a large number of variables with respect to the records. So when such data sets usually are considered to be high dimensional. All right, so the next algorithm that we'll get to learn is the decision trees. This type of algorithm, it's usually called a nonlinear algorithm because it works well when you have a data set that has it does not really take into account those assumptions that we faced for naive Bayes as well as for logistic regression. The decision tree algorithm normally works well with data sets that, yes, you might have maybe some relationship, some variables with relationships, that's independent variables in your training data. Some maybe you could have some of the variables also having a positive linear relationship with maybe the predictor one. So generally, in our situation, it really doesn't matter so much with regards to decision trees. So you don't lose a lot in terms of data. And this type of algorithm works by just recursively splitting the data sets into subsets based on using what are called just decision trees. And it helps you to be able to predict a particular class based on that approach. But generally, decision trees are models or machine learning models based on the decision tree algorithm would normally work for both cases, binary or multi-class. classification problems. You can also interpret them. It's not usually a big deal. Just like logistic regression. The only issue with decision trees is that it can be prone to overfitting, which means it can learn so much from the training data, such that when you introduce new data, it's not able to make predictions that are not correctly predictions that are far off from what it had learned in the training data set. So that is usually something that decision trees tend to face as a disadvantage, but it can be mitigated through the use of what techniques such as pruning. And you could also use some other techniques. These are techniques that you can learn later. There are other techniques that you could do, like you could even decide to use multiple decision trees, like adopt or use what are called random forests, which is just a combination of decision trees for your use case. So that is just decision trees in general. There's KNN, K nearest neighbors. This is another algorithm that helps to perform classification in a way that it only considers the records that it has seen in the training data set, and it compares a new record that you're trying to predict with now the existing records that it had seen, and it tries to figure out which of the existing records look much more closely or look similar to the new record. And then if it sees maybe let's say if you had defined you only want, and by the way, with KNN usually define how many records you want it to compare with the new record. So usually say by initially you can set maybe you want it to be comparing 4 records, to use 4 records when it compares a new record. So if you're trying to make an prediction for a new record, let's say a new customer, we would use their independent variables, and KNN would take that record. It would try to compare that record with now which of the 4 records in the training data set did it see that were closely similar to, well, that are similar, almost closely similar to the new record. And if it finds those 4, yes, it will find. So when it finds those 4 records, it will do what is called max voting or min voting. So it generally looks at, okay, of these 4 records, what was the outcome for those records? Was it a yes or a no in terms of the target variable? And if 3 of the records actually had maybe a yes or a 0 or in terms of that class, then it would assign that class for the 3 records out of 4 to this now the new class. So generally, a K nearest neighbors algorithm just classifies data points based on majority class among the K nearest neighbors in the feature space. That's just an easier way of explaining it. So it just uses neighbors of what it has learned to make predictions. So it's usually simple, effective for binary and multi-class classification. And it's also useful when the data distribution is usually what is called non-parametric, or when local patterns matter. So local patterns are just what I've talked about, which are just the relationship between data points that are only relevant within specific regions or neighborhoods. And it also does not take into account of maybe assumptions about the data distribution or just other assumptions like these other algorithms took into account. Lastly, what we are going to be learning is a support vector machine, which is the other type of algorithm that works really well when you have a data set that has a large number of variables with respect to the records. So in such a use case, we say that it works well with data sets, high dimensional data sets. And it's really able to work for binary classification. Though yes, you can be able to use it also for multi-class problems. It works generally by using just vectors, and all the points within the training data set are usually plotted somewhere within a Cartesian plane. And so SVM, the algorithm tries to create some sort of boundary between those points. So new points that will be given to that machine learning model based on SVM will be either classified on one side of that hyperplane. There's a whole lot again to read about this, but that just gives you a good idea of when you would want to use support vector machines. But just to give you a good idea, when we are working on classification problems, normally we would use all the algorithms to create some just classification models. We could have 5 different classification models: one for logistic, one for naive, one for the decision trees, another one for KNN, another one for SVM. And then we would compare the performance of all those particular records, and then we choose one. But in some other cases, we might even know based on the data set. Once you have studied the data set and you realize this actually data set works really well for logistic regression, you can actually proceed to that. But if you see that actually maybe SVR out of all of them performs best, or SVM, which is support vector machines, performs best, then you can just decide now to continue further optimizing SVM further. So once we have learned about those metrics, those algorithms that we can use to create machine learning models with, you can just then perform evaluation, which involves learning more, using some of these metrics, which we'll go into during our practice work. So there's accuracy, precision, recall, F1 score, specificity, false positive rate, ROC curve or receiver operating characteristic curve, area under the ROC curve, as well as using a confusion matrix to visualize the performance of your model. So why is classification analysis important? So this is just a quick recap. Again, if you want to work towards if you want to identify or perform customer segmentation, especially in many organizations, then you can be able to apply classification analysis. If you want to perform risk management, so wanting to identify and mitigate risks in areas like finance or cybersecurity, then you can do that. Fraud detection, if you want to reduce that in an organization, then you can use data to be able to build classification analysis models or classifiers in that. So healthcare diagnosis, health quality control, churn prediction, text classification. Those are just a few areas where classification would be helpful, and it would help organization be able to save on costs that they might be having. When do you apply? When maybe you want to perform categorization. So if you want to categorize data into predefined classes or groups, when you also want to make predictions about future outcomes based on historical data, when you also want to identify patterns, relationships and factors influencing, say, class membership, so you can be able to also do that. All right, so at this point, I would want to ask you to go through the reading and quiz that we had mentioned a bit earlier. So you find this reading, we've shared this reading as well, and go through the quiz to just assess your understanding of the concepts that we've provided so far. By the way, just to mention a few, if you're an Afterwork member, you have all these resources, and if you've a member of one of the platforms where you're accessing this course, you should also be able to find the resources. But if you're not, you could always just consider becoming an Afterwork member and being able to get the resources that you need to ensure that you get a successful learning experience. Once you're done, we'll come and continue to the practice session, which will involve applying those concepts using now real-life data sets and using Python. All right, so the next thing that we're going to do is to go through the practice work, which you should find also this practice notebook link. Once you open it, you'll get to this page. This is a document, it's a practice notebook that we can use to learn the concepts that we have learned so far. So the first thing that you need to do is to go to File, then save a copy in Drive. And this should save a copy that you can be able to edit and save, and even come back to it later and find those changes that you had made to the document. If you don't, you won't be able to, if you don't do that, if you don't go to File, Save a Copy in Drive, you won't be able to have any changes made and saved in your Google Drive account. So this is just a notebook which generally is a document that data analysts or data scientists use to share their work, because you can be able to also run code inside. So the first thing that we need to do is to connect our notebook. There's usually a button on the far right that says connect. So click on that connect icon, and that should connect this notebook to Google servers. This notebook is hosted on Google Drive, and we can use it. We can actually open it using a Google workspace application called Google Collaboratory, or Google Colab in full, in short. And the idea is that we would normally be able to work on the cloud or in the cloud using now that application. So, and to be able to run the code that we have in our document, we would need to connect our notebook to Google servers. So just do that, and then we can continue. All right, so once it has connected, once you've connected the notebook to Google servers, you'll see at the very top right that it says just has a checklist, just tells you this, that should be it. So what we have done is curated this notebook in the following sections. So we have the importing the necessary library section, example, as well as challenges. So we'll first of all import the libraries that we need to be able to perform classification using Python, and generally to even just work with data. So libraries are just chunks of code or collection of code that we can use, and these libraries usually perform specific tasks. So rather than write code from scratch, we tend to use just libraries to achieve what we want. So let's first of all, let's expand this by clicking this icon and then import these libraries. There are 3 libraries. So there's Pandas, which is a library specifically for performing data manipulation. There's NumPy, which allows us to perform scientific computations if you want to perform conversions. Then even just create summary tables. NumPy usually comes in handy. There's Matplotlib, which allows us to be able to create visualizations. So we might actually Matplotlib, this is the line that we would use of code to do that. This is just part of Matplotlib. So you don't, this sometimes it's necessary, sometimes it's not, but we won't really need this. It's just in case you might need to work with it. So run this code by clicking this cell, and you should not get this pop-up if you had saved a copy in Drive, so don't worry so much about that. Once you have run that, you should be able to see a checklist on a check icon or check on the left. So it means we've imported those libraries. So let's now go through the example that we have. The example that we have for question would be, will John, 40 years of old with salary 2,500, buy a car? So is he likely to buy a car? Assuming that we have we have information about customers, and so we want to know whether they'll be able to buy a car and probably do something about it. So this is what we're going to do. Let's now go through the first stage. So we're going to go through some stages: data importation, exploration, prepare the data for creating a machine learning model, which we'll do in this section. So let's first of all import this data set from this URL. We'll do that using Pandas. This is how we do that, and we store that data in sociodf, which is now a variable, but once we do that, we usually refer to, once we import that data set using Pandas and store it in a variable, we normally refer to that as a data frame. So we have a sociodf data frame. Then we apply the head function to the data frame so that we now have the first 5 records. We can preview the first 5 records of that data set. So this is the data set. Okay. Has user ID, gender, age, estimated salary, and purchased 0 nodes. So this is just a data set with records, past records about customers, and whether they purchased a car or not, that we're going to use now for making predictions. Of course, in a real life setup, you'd have many variables. This is just for learning purposes. So we can also apply the .shape property to our SocioDF data frame to check the size of our data set. So the output, we have records, 400 records and 5 columns. Data preparation, so we move on to preparing our data for further analysis. You might notice for gender column, we actually won't need the user ID column, so we will delete that. For gender column, we will convert this into numerals or numeric form, and we will perform what is called encoding, which just simply assigns every instance of male a 0 and every instance of female a 1. There are many types of encoding transformation techniques, but we will use the most basic form for that task. So that's what we do here, data preparation. We actually perform encoding, but how we do this, we achieve it by simply using NumPy. So here we are actually referencing SocioDF, the gender column, but then we want to equate the values in this particular column with whatever that's on this other right side. So we use a function, a where function from the NumPy library. So np where, inside the function, the where function, we say inside the SocioDF gender column, if the string contains male and also contains female, replace with 1 and 0. So generally, we do that. So where there's an instance of male, we replace with 1. There's an instance of female, we replace with 0. And then we preview the outcome of that, which you can see gender. The first record was male, male. So gender male, that's 1, 1, and female 0, 0. We could actually drop the data set, but we could actually drop the first column, but we haven't done that yet. We actually do that later here. So in our case over here, we decide to prepare our data set for training by separating the independent variables and the dependent variable. So how we do that, we use the iloc method to specify which data needs to be saved for independent variables, and we save that data inside the X variable, and also the predictor variable, that's this column, we save it inside Y. So here we use the iloc method. Double colon will just refer to all records in that table, which is the SocioDF data frame. And then we specify using indexing the columns that we want to consider or to want to select, and also drill down to the values. So we use 1, 2, 3. Normally indexing columns have a position. So and positions usually start from 0. So 0, 1, 2, 3, 4. So user ID is position 0, gender 1, age 2, estimated salary purchased 4. So that's what you see here, and also that's what you see here. So 4, which is purchased, we store it in Y. So if you run that, we should be able to do that. And then the next thing that we do is to split now the two data sets, the Y values as well as the X values that we have, the independent variables and the dependent variable, into a training and a test set. So and the test set, we want it to be 25%, and the training data set, we want it to be 75%. So what we do is we import the test split function, the training test split function from sklearn model selection, and then we use it. So, but before we do that, we create 4 variables. We have xtrain, xtest, ytrain, ytest. So xtrain is the training data set. It's going to contain the independent variables for the training data set. So we'll y for ytrain, we will have the dependent variable values for the training data set. Xtest will contain the independent variables for the test set or testing set or test data set. The same case with the ytest will contain the dependent variable for the test data set. And the trains test split actually creates those 4 different data sets and then assigns them to it assigns them to these different variables. So inside the test split, the train test split function, we specify the the independent variables values and the dependent variable values. That's a target on the label. Then we specify the test size, the size of our test data sets, which will be 25%. And then we set random state to 0 so that we have this data set be reproducible if we give it to someone else. So they should be able to get the same records when it comes to splitting the data set. So let's split the data set into training and test sets. We've done that. The next thing that we need to do is to perform what is called normalization, or we scale our data set so that bigger values such as maybe estimated salary do not have much more impact on the model's performance than age or gender. So we want all the data to be within a specific range, so from 0 to 1. So we use what is called a min-max scaler that will allow us to be able to do that. And this min-max scaler comes with this particular function, fit, and we do that on the train data set. And we also transform, actually we transform both train and as well as X test. And we are doing that for the independent variables, the features. So once we have done that, we have now a data set which is in the right shape and it's the right format for consumption by a machine learning model. The next thing that we do is to import all the algorithms that we talked about. So there's logistic regression, decision tree classifier, support vector classifier, SVM classifier, Gaussian naive-Bayes classifier, there's k-nearest neighbor classifier. So these are just different algorithms that we import, and then we create models from those algorithms. So we start with the logistic regression. So this is a machine learning model based off logistic regression. The same case with decision tree classifier, SVM classifier, KNN classifier, which is the last one, and naive-Bayes classifier. So these are machine learning models, but we haven't gotten to train them. So we need to train them based on the data that we have, which we do using the fit method for each and every algorithm. And we train them based off the XTrain. That's the independent variables for the training data set, and the dependent variable, that's the target values for the training variable as well. We do that for all of them. So let's do that. Let's run that. Once we have done that, the next thing that we need to do is to make some sort of prediction. So be able to use now the trained models to make predictions. So we do that by giving them the X test, the independent variables in the testing data set, to make some sort of prediction. So that's what we do, and we'll store the predictions in the respective variables here. Once we have done that, we then want to compare these predictions and the original values for the X testing data set. So we are going to do that specifically directly. Yes, you can print out those values for X, for Y test, as well as the predictions here. But rather than doing that, we're just going straight to check the accuracy scores for all those particular classifiers and see how well they were able to perform. So we import what is called a classification report, as well as an accuracy score. For the classification report, we will print it out here, which will just give us a summary of the different metrics that we can work with when it comes to evaluating the performance of a classifier. But for now, what we're going to do is just use, first of all, one particular metric score, accuracy score, or one particular evaluation metric, and that will be the accuracy score metric. And we use the accuracy score function, as you can see here, and we pass the logistic, all the predictions that we had here, and also we compare that with the Y test. So this just checks what percentage of these were actually predicted to be similar to this. So this has to be similar to what we have here. So let's run this. And you can see we have 0.89 for logistic regression, 90, 0.9 for decision trees, 92 for SVM, 93 for KNN, and 91 for naive Bayes. So these are just accuracy scores that we can use. So like the one that performed best was KNN, which we could further continue tuning and applying some advanced concepts to. So this is just one method, but sometimes this may not necessarily be useful in just many cases. So sometimes you might want to print out a classification report, which is what we do here for each and every classifier to just get a good understanding of how they were able to do that. And by the way, when you're using an accuracy score, we need to ensure that our data set is balanced. So by balanced, I mean for the values of purchase that we have here for the records, we need to have an equal number of records that belong to each class. If we have two classes, 50 classes, 50% of the classes we need to belong to one class, and the same for the other. So we once we have printed out the classification report, this is how it looks like. So a classification report actually is what we have here. So on the far right, we have support. By 68 and 32, it just means that the records that we have in our data set, 68 of them actually belong to one class, and the 32 belong to another class, which may not be really well, may not come out really well. For precision, so here we have the classes, we have zeros and ones, different classes. We have an accuracy score, which is the 89 that we got. We have macro average, so weighted average. These are just different averages for the different metrics that we have. Here we have precision, recall, F1 score over there. But we have a report for each and every particular classifier that we can be able to drill down further. This is one of the methods that you can use to check on whether, or to check on how well this particular machine learning, or to check which, to check actually how the machine learning models performed using other metrics such as precision, recall, and F1 score. We've provided some few details of what precision, recall, F1 score mean. Like for example, precision would be how many of the records are correctly classified among that class. Recall means how many of this class you find over a whole number of elements of this class. So these are just different, more like advanced metrics, but we'll cover them later. But before you even get to understand what those are, what those metrics are, you would need to learn more about what are these terms. So these are, what does it mean to have true positive, false negative, true negative, false positive. So once you've understood these concepts, then understanding what precision, recall, and F1 score is it becomes a much more easier task, because the idea is that they actually are based off these particular concepts. Like true positive is if the observation is positive, so assuming that you made some predictions with a machine learning model, and that's by positive, it could mean that the numbers that you're looking at, the classes that you're looking at, ones could be positive, 0 could be negative. So generally, you could say if an observation is positive and it's predicted to be positive, then you have, that is called a true positive. Observation is positive for false negative. Observation is positive, but it's predicted to be a negative. Then in that situation, that is a false negative. So in most cases, you want to have as many true positives as possible for whatever problem that you're working with. Same case for true negative. Observation is negative and what was predicted is negative. Then in such a situation, then your machine learning actually performs well when you have more true negatives and true positives. False positive, observation is negative, but the predicted value is positive. Then in that situation, it means that the machine learning correctly predicted. But now these particular numbers. So normally what would happen is that you could represent this in what is called a confusion matrix, which is just generally just a visualization that provides a summary of prediction results. So confusion matrix usually looks actually like this, what you have here. you have 66, 7, 2, and 25. So on the top right, you would have true positive. True positive would be those observations which were positive and were predicted to be positive by the machine learning model. So in such a situation, if you have more of this number, then it means than what you have here. No, more of this number, yes, more of this number than what you have over here, then it means that that your machine learning model actually performed really well. So what comes here, so it's false positive. What comes here is false positive, which means that the observation is negative, but it's predicted to be a positive. Then generally it would mean if you have more of that, then there's an issue. So it means that it performed incorrectly. If you have 2 here, so which is false negative, if false negative, it means that the observation is positive, but it's predicted to be a negative. So generally, you would need to have more of this than here, than what you have here. The same case, you need to have more of this than what you have over here. So you can compare that and be able to get the outcome of that. So it gives you this particular confusion matrix, just gives you a good idea, a drill down idea of how that happens. So I think the next thing that we can do, what can we do? We can print out the confusion matrix for all of them, which you can see here, logistic regression classifier. So what we want is to have the diagonal values, the ones on the far end, top right and top and bottom right, to be more than what you have here. So and the one that actually appears to have lesser values is KNN. Actually, KNN has actually more true positives than true negatives, or no, than false positives. Yeah. So yeah, you can just have a look at this. Use this particular bit for reference. These notes for reference to understand how that happens. So now to answer our question which we had, we wanted to predict whether John, 60 years old with salary 2,500, will buy a car or not. So John, so when we had a few, we had 3 or 4 columns. So if you look at our data set here, we had gender, age, estimated salary, and purchase. So John is male, so we'll give him a 1. Age, we'll give him an age as well as what is there. So let's just go. So going back here, where is it? So John is to represent is a male, so we'll represent that column with a 1, the value for that column. Age 60, salary, which is 2,500, which will represent that. We put this to represent this numerically as a new case. This is how we do it in terms of a record. So the values for this particular use case would be that. Then we transform the values. Then once we have transformed, we're going to use all the algorithms all the models that we've created to predict the new case on whether the value will be a 0 or 1. For the value for this column, purchased would be a 0 or 1, which is now what we want. And let's make that prediction using those models. And you can see actually all of them predicted that John is a 1. So actually, which a 1 means that he's likely to buy a car. So yeah, so that's generally it. So that's it. That's an example of just implementation of all algorithms. And you could always go a step further to tune them, like performing what is called hyperparameter tuning. But for now, the idea was just to understand how to work with these models and be able to use them to make predictions. So work on these challenges that you will find here. And once you have done that, go through the solutions, the solution notebook that we have shared here, and verify your answer. So once you have gone through the solution notebook and also verified all the challenges that you had, we have this project which you can work on. This particular project just involves just application of those classification analysis concepts that you've learned so far. Apply those concepts in this project. We've provided a guiding notebook if you scroll downwards, and use the notes that we provided inside the guiding notebook to complete it. You would just be able to go through. For the first few sections, we've already curated, we've already put some code for you that really doesn't involve classification analysis, but for the classification analysis bit, you would need to apply those methods that we had mentioned, we had seen. And once you have done that, you can also verify your solution using the solution notebook. And you could also, if you want, submit a project for just personal review. Could review them, or the team at Afterwork could review them on the Afterwork website, and we can give you feedback. And that's it. That's generally it. That would be the learning experience when it comes to working with classification analysis. I hope you're able to learn much from this learning experience. And the idea is that for you is that you can be able to put into practice those concepts in a real life scenario. The next step, so once you have worked on the project and you have been able to come up with a solution that works best for that, you can always use that project for your portfolio. Once you have completed the course, you can now look into now using what are called Ensemblo learning or Ensemblo methods with Python. And this would just involve what we have done, but only using now a combination of those particular models to be able to make decisions. There are algorithms which actually make use of multiple algorithms to be able to have a model or machine learning model that's far much more accurate than these models that we've learned, which are called base models. If you still are a beginner and you'd want to start learning, just go back to Introduction to Python Programming, go through all the courses that we've provided, and hopefully by the end of it all, you will come out a better person who's able to make or create solutions that solve real world problems. All the best in your learning journey. And if you have any questions, please ask them in the chat or comment section of whatever platform that this course has been hosted in. We'll be more than happy to respond and get to engage with you further. All the best in your learning journey.